Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm wondering, why does my sweet corn do this when it's cooking? Hopefully by the end of this video you should be able to say what convection is, where convection takes place and why it takes place. So previously we found out that thermal energy can be transferred through solid materials by the process of conduction. Okay, that's because the particles are nice and close to each other and they're in fixed positions. Okay, now this doesn't happen to materials that are in either their liquid state or their gaseous state. Okay, the particles are too far apart and they're free to move about each other in a random way, meaning the vibrations or the kinetic energy can't be passed between the particles. So how exactly is energy transferred in a fluid? And both liquids and gases are a fluid. A fluid is anything that can flow. So liquids and gases can both be referred to as fluids. So how can energy be transferred in a fluid? It's by a process called convection. Convection is the process that transfers heat in a fluid. So before we move on, let's just remind ourselves that when you heat up a material, the particles gain kinetic energy and they move about more, which means they take up more space, okay? So that means that the material becomes less dense, okay? The density decreases because the same amount of mass is now occupying a larger volume. Now it's this change in density which is what actually causes the movement of our fluid. It should be obvious to us really that more dense things like this metal bolt or the thick gloopy honey at the bottom of my jar here are going to sink below the less dense, lighter things like the lamp oil at the top or the ping pong ball, which is full of air. We've all seen a dense, heavy stone sink below less dense water. So it's the difference in densities which allows our fluid, and therefore the energy it's carrying with it, to start to move about. So let's actually see what goes on here. Okay, I've got a beaker of water there that I'm going to start to heat up with my Bunsen burner. Okay, and when I start to heat up the water, the area of water directly in front of the Bunsen burner starts to heat up, and of course the particles there are gaining kinetic energy, and as they gain kinetic energy they start to move about more, and that piece of water becomes less dense than the water that's surrounding it. So this area of water here is less dense than all the water surrounding it, and we know that less dense things start to float to the top and more dense things start to sink. So my less dense water begins to rise to the top of my beaker, and as it does so it starts to take the thermal energy with it. So the less dense water rises up, taking with it the thermal energy I've given it from the Bunsen burner. Now, at the same time, cooler water at the top of the beaker is now heavier or more dense than the water that's rising up. So this cooler water now starts to sink down towards the bottom of the beaker. But of course, what happens when it gets down to the bottom of the beaker? It's next to the Bunsen burner, so it itself starts to get hot. The particles gain kinetic energy, they move about more, and so this water now starts to rise towards the top of the beaker, and more cool water sinks down to replace it. Okay, this process just repeats itself, and what we have here is what we call a convection current. Okay, and that was actually what was making my sweet corn move about inside of my saucepan that we saw at the beginning. So let's actually see this in action. In my container here I've got some really cold water, and in my tiny bottle over here I've put a little bit of dye in, and I'm just going to fill that up now with some just boiled water. So I'm going to do this very carefully not to burn myself. So now we've got really hot water. The dye is just so you can see what's going on. Okay, so we've got a little bottle full of really hot water, and my big container contains really cold water, and if I carefully lower my container in down to the bottom, okay, a little bit comes out on the way, but what we should see now is that the hot water inside is less dense than the cold water outside, so it starts to rise up because of the convection current, and you can see that the warm water is rising up because it's less dense than the cold water around it until it gets to the top. When that green water at the top gets to the top, it starts to cool down, and we might see some of that green start to sink back down as that water becomes colder again. But I think that's a good demonstration there of the hot coloured water is less dense than the clear cold water outside the bottle, so the hot water rises. So that's how heat energy is transferred in a fluid by the process of convection. And you've probably seen this before if you've ever seen a hot air balloon. They rise up because the warm, less dense air inside them tries to rise above the cooler, more dense air outside. That's why they tend to rise up in the air. If you've ever seen a seagull soaring about at the seaside without any sort of effort at all, what he's actually doing is surfing along on rising warm air currents, okay? Cold air comes in off the sea, warms up when it gets over the land and rises up in a convection current. So that is what we need to know about thermal energy transfer in a fluid and convection. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.